This video is on the objective solve linear trigonometric equations in sine. And this is the second video on this objective, so hopefully you've watched the first one. I'm just going to get into it. So again, if you want to see more about the topic, what they have to say about it, click on more instruction. Look at their videos, their notes, their examples, and hopefully those help you out. Alright, so here we're asked to solve for theta. Right, if negative 12 times the sine of theta equals negative 6 times the square root of 3. And, they're looking for the solution, because remember my first video, these trigonometric equations, if there are solutions, there's going to be infinitely many of them. So you see they're cutting down the range. They only want the solutions that are from 0 to 2 pi, the values of theta that make this statement true, that are from 0 to 2 pi, but not including 2 pi. And list your answers separated by commas if you need to. Alright, so I'll go to a piece of paper and write this out. Alright, so our equation here is negative 12 times the sine of theta equals negative 6 times the square root of 3. Alright, now if we're to isolate the sine of theta and get that sine of theta alone, I would just be dividing by negative 12. And divide both sides by negative 12. That gives me the sine of theta alone on the left like I want. And then negative 6 over negative 12 is positive 1/2, so I have half of the square root of 3, or the square root of 3 divided by 2. And this is a nice special number. You should know some angles that have a sine of the square root of 3 over 2. So first I'm going to write the general solution. Alright, I'm gonna write out a description of all the infinitely many solutions of this equation. So again, to do that, I'm going to think of once around the unit circle. Alright, think of going once around the unit circle counterclockwise. And when I go once around the unit circle counterclockwise, what angles, what values of theta have a sine of positive square root of 3 over 2? Well, one of those angles was pi over 3. Right, pi over 3 radians, 60 degrees if you're in degrees. So pi over 3 is a good solution to this. Also though, if we go to pi over 3, if you add 2 pi, subtract 2 pi, add 4 pi, 6 pi, you end up at the same position. You get a coterminal angle. So to describe all the infinitely many solutions that are coterminal with pi over 3, I just add any multiple of 2 pi. So plus 2 pi times k, where k is an integer, right? 0, 1, 2, 3, negative 1, negative 2, negative 3, etc. But that's not the only angle. Pi over 3 in quadrant 1, that's not the only angle that has a sine of square root of 3 over 2. There is also an angle in quadrant 2 that has a sine of square root of 3 over 2, and that would be 2 pi over 3, right, 120 degrees. So, or, theta could be 2 pi over 3. And then any angle that's coterminal with this would also have a sine of the square root of 3 over 2. So plus, some multiple, any multiple of 2 pi, so plus 2 pi k. All right. So again, here's a description of all the infinitely many solutions this equation has. And then I'll list a bunch. Right? I'll list a bunch. And at the end, we're just going to write the solutions that are from 0 to 2 pi. So that would just be pi over 3 and 2 pi over 3. Alright, but for right now, again, I like doing this. You've seen me do this in other videos. Just to get a feel for what the solutions of these equations are like. So again, I just replace k with different values, different integers. K equals 0, k equals 1, k equals 2, etc. K equals -1, k equals -2, and so on. Now when k equals 0, you're just getting the pi over 3 and the 2 pi over 3. Alright, and I'll just work with this top equation first, this top set of solutions. Now, what I'm doing is I'm going to be adding 2 pi and subtracting 2 pi to get other solutions. Now I need a common denominator, right? When you add or subtract, you need a common denominator. 2 pi is, 6 pi over 3. So I'm going to keep adding 6 pi over 3 and subtracting 6 pi over 3. So when k equals 1, another solution I'm getting is 7 pi over 3. And then when k equals 2, I'm getting a 13 pi over 3. And then 19 pi over 3, and so on. Alright, I'm just keep on adding 2 pi, keep on adding 6 pi over 3. And going backwards, when k equals -1, I'm subtracting 2 pi. So -5 pi over 3 is another solution. Then -11 pi over 3 when k equals -2 is another solution. And I can do that all day long. Alright, and the same thing for 2 pi, this other branch. 2 pi over 3 is a solution, and I can also just keep adding or subtracting 2 pi, which is 6 pi over 3. So 2 pi over 3 plus 6 pi over 3, 8 pi over 3 would be another value of theta that would work in this equation. Another solution, 16 pi over 3, I'm sorry, 14. Ugh. Can't add. 8 plus 6 is 14. 14 pi over 3, then 20 pi over 3, and so on. And then going this way, when k equals -1, I'm subtracting 6 pi over 3, so -4 pi over 3 would be another solution. -10 pi over 3 would be another solution. And again, I can do that all day long. So here's 10 solutions to this equation. But we're only asked for the ones that are in this range, right? We want the values of theta, we want the solutions that are only between 0 and 2 pi. Alright, and those solutions are, these numbers here. Alright, those are the only two solutions that are between 0 and 2 pi like this. Because all these are too big, all these are bigger than 2 pi, and all these are too small, they're all less than 0. So what I'm going to eventually be typing here are these two solutions, the pi over 3 and 2 pi over 3 are the solutions to this equation that they want. And that's what I'll be typing. And again, you can always go back to the original equation. Alright, this was the original equation. Plug in pi over 3. Alright, the sine of pi over 3 is the square root of 3 over 2. Then times -12 would be -6 pi over 3. So that works. And the same thing for 2 pi over 3. It would also work back in the initial equation. Alright, so here the way I'm entering this is, you don't have to type theta equals, you're just typing the solutions. So pi over 3 was one of them, and then separated by commas, right? Then a comma, and the other one in the range that they wanted was 2 pi over 3. And that was it, right? Those are the only two solutions in that range. Okay. So again, hopefully watching me do this, or looking at more instruction or reading the answer explanations here, hopefully all this stuff helps you out when you work on it on your own. And thanks for watching.